Hi everyone, welcome back to Eve Math Tutoring. Today's lesson is on graphing lines using the slope and y-intercept. So I'm going to start off with an easy example. So say you're given an equation that's already in the form y equals mx plus b. So now actually before I do that example, sorry, let me just take this back. I want to explain something. So when you have an equation in the form y equals mx plus b, m represents the slope of that equation, and b is the y-intercept. It's where the line crosses the y-axis. Okay? So if you're given an example and you're asked to, say, plot the line or graph the line or graph the line, and you're given y equals, say, negative 2x plus 3. So something like that. Now this equation is already in slope-intercept form, so it's in the form y equals mx plus b. Doesn't matter what your m is or your b is. They can be positives or negatives. So because it's already in this form y equals mx plus b, it's going to be easy to graph it on a grid. Okay, so you're going to set up your graph. Here's your y-axis and this is your x-axis. So now we can start off with a number of things. So we know that the y-intercept is 3. So that means that the line crosses the y-axis when x equals 0 at 3. So we're going to put a point here. So as you remember, in a previous lesson I had mentioned that when x equals 0, that's when you get your y-intercept. So your y-intercept is going to be the point 0, 3. Okay, and that's given by this number here. So you don't look at anything else, just look at this number here in the equation. So this here is your y-intercept, so it's at 3, 1, 2, 3. And then the slope of your equation is negative 2. So we know that slope, m, is rise over run. So in this case, our rise is negative 2 over 1. The 1's not written, but we know that in numbers, when there's no number written below the number, there's actually always a 1 there. So we're going to use this information to graph our line. So we have a rise of negative 2 and a run of 1. So that means when I rise to 1, 2, so I rise 2 units and then I go to the right by 1 unit. So rise 1, 2, and run. And then what you do, oops, I went the wrong way, sorry. So I'm just going to delete that, sorry. Okay, so now if it was positive 2 over 1, that's how I would have drawn the equation. But because it's actually negative 2, we're going down. So it's a rise of negative 2, so I forgot that part. So that's going down 2 and a run of 1, which is positive 1, so that's to the right. Okay, so we go down 2 and over to the right, so we connect those two, and we've just plotted our line. We've graphed the line, okay? Now, when you have a rise number, rise over run, okay, so when your rise is a positive number, you are moving up in your graph in the y direction. When your run is negative, you are moving down. Rise. I'm talking about rise, sorry. When your rise is positive, you move up. When it's negative, you move down. When your run is positive, you move to the right. And when your run is negative, you move to the left. So a positive run goes this way, and a negative run would go the other direction. Okay, so starting from one point to the other. Usually it's good to start off with your the y-intercept first, and then once you do that, you can easily figure out where to go using the information given to you by your slope. Okay, so that is how to graph a line using the y-intercept form. I'm going to do an example of an equation that's not given in this way and how we would convert that into the proper format and then graph it. So I'm going to actually try this example right here. So we're going to graph the following. We're going to graph 3x plus 2y minus 12 equal to 0. So what we want to do here again now, before we graph this, we have to get it in the form y equals mx plus b. So what I have to do is I have to isolate y and move everything over to the other side. So I'm going to keep y on the left side, and I'm going to move the other two numbers and variables over to the right, to the other side of the equation. And as you remember, whenever you move something to the other side of an equation, it changes signs. So because this is positive here, it's going to become negative when I move it to the other side of the equal sign. And because this is negative, when I move it to the other side of the equal sign, it's going to become positive. Okay, so I do that first, and then I want to get y by itself. So what do I have to do? Well, I have to divide this by 2. And whatever I do to one side of the equation, I have to do the same thing to the other side in order not to change the equation. So when we do that, we get y equals negative 3 over 2x plus 6. So now we've got the equation in y equals mx plus b format, which is what we want because it's easy to graph when we have it in that form. So now that I have it in that form, I can see that my y-intercept is equal to 6, and my slope, rise over run, is equal to negative 3 over 2. Okay, so I'm going to use that information to actually graph this. Okay, so the y-intercept is 6, so that is when x equals 0, so that gives me this point here. 1, 2, 3, 4, 5, 6. So I draw my y-intercept first, and then my slope is negative 3 over 2. So that means I have a rise of negative 3, so I move down 3 units, and a run of positive 2, so I move over 2 units, and then I put in a point there. And then what I can do is I can actually graph those two together. Okay, so that would give me that part. Now, if you notice here that, you're drawing the line and you're not really sure where it crosses the x-axis, you can always keep in mind that you can find the x-intercept by setting y equal to 0, right? So if you want your graph to be, but then we kind of be graphing using x and y intercepts, which is a completely different way of graphing. But again, as a side note, I would probably do that here because I would be worried that it wouldn't be too accurate. So what I would do actually on the side is I would just set y equal to 0, and then I would try to find my x-intercept, because I think in this case it would be useful to do that. So when we do that, so over here we would obviously multiply both sides by 2 to get rid of this. Actually, if we multiply both sides by 2/3, that would eliminate the fraction completely and divided both sides by -1. So we're going to multiply both sides by 2/3. I'm just canceling out the negatives. 2/3 by 3/3 halves would just cancel. So this would be 2 times 6, which is 12, divided by 3, which is x, and x would equal 4. So that means that over here would actually cross at that point. So to be very accurate, I could use that information as well. Using just the slope-intercept form, I could just graph it. It would still be, this is still correct, but if you wanted, to also show where it crosses the x-axis and you weren't 100% certain, you could always do the x-intercept, right, which is when y equals 0. So that would be 4, 0. That's just a side note there for that last point I just put in. But this here is graphing using the y-intercept and the slope. Okay, so that's that one. And there's, yeah, so I mean, they're all pretty much similar. So that's pretty much graphing. I'm just thinking if I should, if I should do an example with a positive slope. So looking back here, it looks like I did 2 examples with negatives. I'm going to do one more example, and I'm just going to do one with a positive slope. So let's do one like that. So we're going to graph. So maybe something like y equals 5x plus 2. Okay, so over here our slope is equal to 5 rise over run, and that's obviously 5 over 1. If there's no number, if it's not a fraction, just always write it over 1. Like I said, as you know, every number is actually written over 1, we just don't see it. And then so that's the slope, and then the y-intercept in this case is 2. So using that information very quickly, I could do a quick graph of this. So here's my y-axis and my x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're going to do the y-intercept first. So it intercepts the y-axis, or intersects the y-axis at x equals 2. When x equals 0, y equals 2. So it's at 2 over here. And then our slope here is positive this time. So this time our rise is going to go upward. So we're going to go 1, 2, 3, 4, 5. And then our run is positive. So that's going to go this way. Okay, and we would just draw it like that. Now, we could do an example where we have, if we had, say, I'm just going to switch it up here. So say we had an example where it was the same intercept, so plus 2, but this time our slope was negative 5x. That would probably be going in this direction. Okay, now if we had this one, say, so then we'd be here, and then the rise over run this time would be negative 5. So that would actually be going 1, 2, 3, 4, 5, and then over 1 again. So that would be something like this. Okay, so you can see how different this one is than this. So that's the slope, because it's a negative slope, it's going from left to right, it's going down, and this one, because it's positive, from left to right, it's going up. Okay, so that's another example there. But anyways, that's just a side note, so just keeping that in mind. So that's really like how you would graph using the slope-intercept form. I find this form really easy when it comes to graphing, but I also find the x-intercept, y-intercept of an equation very useful when trying to graph the line. I find that actually extremely useful. And then of course the other way to graph lines is using a table of values, which also works as well. So those are like the 3 main methods of graphing lines. Okay, so I hope you found that helpful. Okay, bye-bye.